Oil-fired power generation. What is oil-fired power generation? Power plants that burn oil to produce electricity are called oil-fired power plants. They are no different in general principle and operation from their fossil fuel cousins, the coal-fired and the natural gas-fired plants. Heavy fuel was once a significant source of energy for electric power generation. After oil prices increased in the 1970s, oil was displaced by coal and later on with natural gas. Liquid fuels may also be used by gas-powered turbines, especially for peaking or emergency services. Distillate oil is still important as the fuel source for diesel engine power plants, used especially in isolated communities not interconnected to a grid. As you can see in the picture, it is a power plant that is not connected to a grid. Next, oil has advantages of easier transportation and handling than solid coal and easier on-site storage as it is liquid. Now I am going to explain to you the basic operation of oil-fired power plant. Firstly, by turning the shaft of the generator, we will be able to generate electricity. The generator derives motion from a steam turbine, the heart of the power plant. In order to turn the steam turbine, you have to supply a high pressure and high temperature steam at the inlet of the turbine. As the turbine absorbs energy from the high energy fluid, its pressure and temperature drops toward the outlet. High capacity power plants often use different stages of steam turbines, such as high pressure turbine, intermediate pressure turbine, and low pressure turbines. So now we have met our objective. We have produced electricity from the generator by moving these turbines. If we can bring the low pressure and low temperature steam back to its original states, which were of much higher pressure and temperature, we can repeat the process. The first step is to raise the pressure using a condenser. A stream of cold water flows through the tube. The steam rejects heat to the liquid stream and becomes condensed. Now we can use a pump to increase the pressure of the feed water to its original state. The next task is to bring the temperature back to its original value. For this purpose, heat is added to the exit of the pump with the help of a boiler. Next, oil is burned inside the boiler. The incoming water initially passes through the walls of the boiler, heating up the water created by the burning of fuel, where it transforms water into steam. And finally, the steam is channeled into the steam turbines, thus rotating and generating electricity. Also, an extra information, the condenser needs constant cool liquid. Cool liquid is supplied at the condenser with the help of a cooling tower. The heated up water from the condenser outlet is sprayed in the cooling tower, which induces a natural air drift and the sprayed water loses heat. This is how a colder liquid is always provided at the condenser inlet.
Assalamualaikum and hi, my name is Anis Azila binti Arman. So next I'm going to explain on basic construction of oil-fired power generation. So do you know fossil fuel power plants burns coal or oil to create heat, which is in turn used to generate steam to drive turbines which generate electricity. So here is a diagram of oil-fired power generation, which is also known as fossil fuel power station. So here I'm going to explain the components that involved in fossil fuel power station. First is boiler. In the boiler, heat from the furnace flows around pipes full of cold water. The heat boils the water and turns it into steam. Second is steam turbine. The device is designed to convert the steam's energy into kinetic energy. 3 is exhaust, which is channeling the smoke out 4 is cooling tower. The giant jug-shaped cooling towers you see at all power plants make the turbine more efficient. Boiling hot water from the steam turbine is cooled in a heat exchanger called a condenser. 5 is generator. The turbine is linked by an axle to a generator, so the generator spins around with the turbine blades. As it spins, the generator uses the kinetic energy from the turbine to make electricity. 6 is transformer. Is used to increase or decrease the voltage. So here is some infos regarding the fossil fuel. So fossil fuels comprise mainly of coal, oil and gas. These three were formed millions of years ago beneath the Earth's surface from the decomposed bodies of dead plants and animals. They are foreseen to be in a short supply in the future as man's fuel needs continue to grow at a fast rate. Second is crude oil is also referred to as petroleum. Compared to coal, this is easier to extract from the ground through the use of pipes, thereby making it less costly to transport from one place to another. So we move to the advantages of oil-fired power generation. First, oil power plants can be fed by large tanks or pipelines. These can provide a constant supply of oil for the uninterrupted operation of the plant. Second, oil is so readily available. It is a cheap solution in helping to meet global energy requirements. Third, once extracted from the ground, we can store oil in barrels or tanks. This allows us to keep reserves of oil readily available. So next is the advantages of oil-fired power generation. First, crude oil is a non-renewable resource, meaning it will one day run out. Second, oil releases sulfur dioxide gas when they burn, which may contribute to acid rain. Lastly, oil energy also produces greenhouse gases which contribute towards climate change. So here I provided some pictures of oil-fired power generation. So in the picture is where Japan restarts the old oil-fired power stations, and here is where Power China constructs world's largest oil-fired power plant in Saudi. So we move to the examples of actual oil-fired power plant generation. So in the picture here is at Riyadh crude oil-fired power plant. Saudi Consolidated Electricity Company Central Region (SCECO Central) serves the Saudi capital Riyadh and the surrounding region. SCECO has been consolidated together with the other regional power companies into a single joint stock company. So we go to the next examples, which is at Subia oil-fired power plant. Stage 1 of the Subia oil-fired power plant in Kuwait was completed in year 2000. So 8 300 megawatt boilers and turbines are now producing 2,400 megawatt and up to 12 million gallons per day of drinking water at the $2.2 billion Subia 1 plant. The 2000 megawatt Subia 2 plant is gas-fired and should increase drinking water production to 96 million gallons per day. So here is some references I attached to produce this video. Thank you.